In this lecture, we'll learn about the register calling conventions. This lecture will be recorded into two parts. Let's first study the register saving and restoring calling conventions. Let's say that you have a function foo, and this function foo has a call to a function bar. We use the jump and link instruction for the call to function bar. And then there is a return statement. We use the jump and link return instruction for the return. There are several other things that the function does that are not important for our discussion. Then we have a function bar that eventually executes a return statement. When discussing properties of a program, it's very important to refer to the points in the program that we are interested in talking about. So first of all, for this specific call, foo is the caller and bar is the callee, as we saw in previous lecture. Now let's consider the different points of execution in this program. So let's consider the point immediately before the call to the function bar. And let's consider the point in the program immediately after I return from executing that function. Let's consider the point in the function bar before I do anything else. So I just arrive at the function bar. That's a point that I'm interested on. And let's also consider the point in the function bar immediately before the return statement. So those are the 4 points in the execution of this program that I'm interested for this discussion right now. And I have several questions that I would like to ask about these points. The first question is related to the values of that are stored in all the registers in the processor at this point immediately before the call to the function bar. And the question that I have is, are the same values still there when I return from the function bar? And in the function bar, I have the question of, can the callee, that's the bar, simply write over the register values? Of course, if I simply write over the register values, then the answer to the question in the caller is no, the values are not going to be there because the callee may have just written over them. Or does the callee need to save the register values before using them? And saving, of course, would imply saving them to the stack. And the other question is, what do I need to do at the point immediately before the return from the callee? To answer those questions, we will examine the register saving and restoring conventions for RISC-V. And those conventions state the following. Any values that are in the register S0 to S11 immediately before a call to a function must still be there, the same values must still be there when I return from the call. Therefore, the callee must save the values of S0 and S11 if it changes them. Of course, if the callee doesn't change those values, there's no need to save them. They are not gonna be affected. So they'll have to be saved in the beginning of the callee, and the callee must restore those values prior to return to the caller, the ones that had changed. This way, I have the guarantee that once I return from the function call, the values of S0 to S11 have not changed, and that's why they are called the saved registers, thus the name S. So that's what we have for the caller side. Let's see, so S0 to S11 are the saved registers because their values must be preserved by a function call. The values that are in T0 to T6 or A0 to A7 immediately before the call cannot be assumed to be the same after the call. The callee is free to change them as it wishes. So the callee can use the register T0 to T6 and A0 to A7 without saving them. There is no need to restore them. The T0, T6, and A0, A7 are temporary registers that are not preserved by during a function call. So registers used for procedure calls include the A0, A1. Those are two argument registers in which I pass parameters to a function. These very same two registers are also used as the return values from a procedure. So in RISC-V, the two first argument registers are also the two return value registers that are used. I have more argument registers. I have A2 to A7 as additional another 6 argument registers that I can use to pass parameters to a procedure. There is the array, that's the return address registers that returns the point after the call. So far we have seen, if we summarize, x0 is the register 0, x1 is the return address, the register 2 is the stack pointer, the register 3 is the global pointer, the register 4 is a thread pointer, which we have not discussed yet. The registers 5 to 7 and 28 to 31 are the temporary registers from T0 to T6. Register 8 is both S0 and the frame pointer. Registers 9 and 18 to 27 are the remainder saved registers from S1 to S11. The registers 10 to 11 are A0 and A1, that they are both arguments to functions. They are the first two arguments to a function, and they also contain the return values when I return from a function call. And then I have the registers A2 to A7, that is the 12 to 17 registers that are function arguments. So now we have a picture of all the registers in the RISC-V processor. So one way that we can understand better this calling convention is with an illustration. And here's the illustration that we're going to use. Assume that there is some kind of large city, and we have the caller in one side of the city and the callee on another side of the city. And the caller is working on some computation, so there is the state of the program, and when asking for the help of the callee to do something, the caller will send over the state of this program to the callee. When sending over the state of the program, the caller will have the assumption that anything that he has in S0, S11 will be preserved by the callee, and when the status comes back to him, those values will be preserved. And he will assume that anything that's in T0, T6, and also A0, A7 is garbage, which means the callee is free to do anything that it wants with those registers without saving. So what the caller will be thinking is, if I have anything that is of value in T0, T6, I must save it somewhere before I make a call to the callee. And the callee will preserve the values of S0 and S11 for me. This is our contract. On the other hand, the callee will think that T0 and T6 are blank registers. They don't contain anything that the caller cares about. And S0, S11 are registers that I need to be careful about, because anything that's there, the caller probably wants to know, wants those values to be preserved. So therefore, the callee will think that I can use T0, T6 without saving them, but I must save S0, S11 before I can use them. So as a recap, let's see what we learned in this part of the lecture. We have learned about the register usage convention, and we have learned that there is a convention that the caller will expect the register S0 to S11 to be preserved, and will expect that the values in T0 to T6 and also A0 to A7 to be changed by the callee, or that they can potentially be changed. And the callee on its part will say that T0 to 7 are T0 to 6 are blank registers that it can use at will without saving. But if it uses one of the saved registers, it must save them before using them.